live on YouTube, and I think we're good. And let me just make sure that in feed loop, we are indeed showing up. So I see we've got participants are trickling in. I like to say, find your seats, pretend that they're finding their seats. And I think we are streaming. I think we're all systems go. So that's really great. So welcome everyone. It's a great pleasure to have Jana talking with us live to give us a Q&A session. I'm sure I've seen we've got a bunch of people who viewed on YouTube, and I know that's a lower estimate because I know a whole bunch of people have also been viewing the video on FeedLoop. FeedLoop is the slightly higher quality version, I think. And so, Jana, first of all, thank you for joining us. It's great to have you.
Thank you so much for having me. Thanks so much.
And I really enjoyed the talk. I have to say, I'm amazed by sort of how much you had to say, and how much you also said that you could have said more about. So that was really great. So I thought we would start. So first of all, I want to say to our audience, click on the Q&A button and send us a Q, and you'll get an A. But just to get us started, I'm someone who's had a little bit of experience with LTL, but I've never written a paper that involves signal temporal logic. And one of the things, Jana, you did really nicely was to talk about in the beginning. You kind of actually gave a history of formal methods in robotics a little bit. And so I kind of like that because I learned a lot from that. I didn't kind of realize, if you read individual papers, you don't get the overall picture. You kind of see bits and pieces. And one of the things that I have seen is I've seen more of these papers which are talking about signal temporal logic or fragments of signal temporal logic. And so what I got from your talk was, first of all, we see this as a progression. Initially was LTL, and now there's more stuff which is using signal temporal logic. Can you say a little more about what that is at sort of a tutorial level, just for me?
Sure, not just for you, for everyone, I can. So I have to say that when I was building that slide, it came out like I wanted to give credit to everyone who did this development, and I started filling out slides with names, and then I realized I'm never make it complete in half an hour. So sure, LTL was there in the beginning, and it's built over propositions, so it's more suitable for high level tasks like mission and motion tasks and goals and objectives. And it's in pure LTL, you don't get any explicit time or any kind of dealing with signals. So everything is propositional. It's very discrete, which makes it a little bit easier to handle. Easier as in computationally more efficient, and you can apply various frameworks like automata-based model checking and all these kind of things, and handle LTL as it is. And then you can get also these fragments, like I was mentioning, GR1 or SCLTL, that are easier to handle, even easier. And very often you don't need a full LTL, so you're happy with GR1 or with syntactically co-safe. Now, on the other hand, if you want to go a little bit lower level in what you want to say, or if you are thinking about robots as things that have deadlines or explicit timing requests, you need to add on top of LTL. And what we are adding are these time constraints, and are these functions of signals compared to zero, and that's the signal temporal logic. So somewhere in between is also metric temporal logic. Metric temporal logic has only the time, not the signals. Now, the price that you pay for doing that is, of course, that a lot of tools that are available for LTL are not available for STL anymore. But you can still do quite a few things. You can still discretize. You can discretize the semantics of STL in a way, and then you can do some stuff. Now, I think that there was one important thing I wanted to say that I forgot. So it was probably not so important. Yeah, okay, that's probably the difference. Yeah, I know what I wanted to say. STL is a little bit more suitable to expressing things about motion planning to control level thanks to these signals. And so that's how I view it. So LTL is more for mission, STL is more low level. And then if you think about, temporal logic framework for mission and motion planning and control, then you can work with all these logics on all those levels.
I see. Because yeah, certainly the examples I've seen, you gave an instance where you had kind of room labeled A, room labeled B, and that makes sense. I mean, you were talking about LTL at the time, and now you're saying, well, when you go to signals, and that's actually one of the things that I found quite fascinating about the breadth of the work that you spoke about, was that some of these are on a robot stack quite low level, as you say, like you're making extensions to RT star, or you're thinking about motion constraints, you're thinking about safety constraints. And so that definitely, it's interesting because it's sort of progressed from the task level down to think a bit more about the actual details of robots. So one question I'm kind of curious about is, how does this work? Do you have a foot in that community, the formal methods community, the theoretical CS community, and the people who build the tools? Or is it that you kind of think about it a little bit and then you go to them and say, you guys haven't figured out exactly what we need? I guess what I'm wondering is are we stealing from them, or are we kind of also giving them back some ideas?
We are definitely, it's a two-way street, definitely. And it's not actually just two-way. I think that control theory is the third party in this whole thing. So there is the TCS, there is the control theory, and there is robotics. And I think that people, I'm an in-betweener. So for me particularly, it works that way that TCS people come to me and they're like, can you give us a concrete example of something? You are the roboticist here. And then I go and I talk to robotics and I'm like, I have these tools, how can we help you? So it's definitely going it's all a lot about the three communities communicating together and exchanging ideas. It's a little bit about robotics coming to us and saying, you have these tools, is there somehow you can help us? But it's also how can we help you? And usually it's really funny, because the one thing that we realize is that when we come to robotics, we do not need the whole thing that we are developing in theoretical computer science. It's like we have so many different tools and such exotic logics and so many different things to offer. And then when we come to robotics, what the people there need is usually way simpler than that. We just need this little tiny part of what you can do, and then that inspires TCS people to start developing things that fit that particular scenarios or something. So I think that's very meaningful relationship there.
All right. Well, but it's driven because there are people like you who are kind of these bridging or interface people who can kind of speak both languages in some sense and understand the values of both sides, I guess. So Mike, one question I have, because we've actually gotten several questions from graduate students who've been asking about sort of career advice. And after all, it's an early career talk. And so, you're an exemplar. So one question is, how did you position yourself to be someone who's kind of a bridging person between these communities? Do you have an advice, or is it, you woke up one day and
No, I really did not. It just happened. It was like a sequence of really cool coincidences. So I was incredibly lucky to meet the right people at the right time and just work on the right project at the right time. And then I took it from there. I said yes to everything. So, which is also a really bad advice to say yes to everything, but yeah.
Well, but so, I mean, that's one thing I did see. If you look at, all the work you spoke about, your work as a graduate student, your work as a postdoc, and with, the golf carts and MIT Alliance, and you've done a lot of stuff, and actually the breadth of the applications. I mean, you had these examples of low-level motion problems. You have self-driving cars. You have manipulator problems. You have a humanoids paper. You have multi-agent. The breadth is incredible. And
but that's precisely thanks to, just being open-minded to collaboration, talking to people and asking what do you want and so on. And this is also thanks to the group that I have been building. I mean, it's just the nature of the people. I've got the control people there, I've got TCS people, I've got roboticists there, and when they start talking, this is what's coming out. So yeah, that's that.
Yeah, well, I mean, it's a recipe which is working. So I mean, it's definitely something for us to learn from. So I'll pause for a second here just to see if I can try to solicit a question from the audience. Does anyone? We do have anonymous questions. You don't have to put your name on that if you just want to type that in, or if you're more than that, you would like to come to the microphone. If you raise a hand, I can enable your audio so you can ask a question. If you don't, I've got plenty of questions because I thought this was a very fascinating talk and there are a lot of things, but I don't want to drown out everyone. After all, by the end of this conference, you will have seen enough of me talking, and so no one. Okay, all right. So one thing I thought was I really liked was your division into these challenges. So I really love this phrase, correct enough. It made me think about Colbert, who talks about what is it? Something which is like not quite true, but truthy, right? Something like that. And so I think it was kind of interesting. I mean, so I have read a little bit of those papers where you talk about these sort of qualitative semantics that you add, and then talk about minimum violation. The thing that I found really interesting, and we have got a question here, but I'll just finish this, is that in several cases, you were talking about safety, or you're talking about here's something we can do. And then it was like there was a twist in the tail of the story, because it turned out that when you did exploration, which is, I didn't know at all about anyone who had applied formal methods, techniques to exploration. Then it turns out it was faster and even more complete. And you didn't start by saying we want something faster and more complete. We want something which is more like this. And then it turns out that was faster and more complete. And later on, you spoke about the motion primitives for the other challenge, right? When you don't have a model, and then you said, oh, it turns out this is 10 times faster, which,
yeah,
again, it seems like you guys try something and then you seem to have these tools which then, they deliver more than even what you're looking for, which is really cool.
Yeah, I mean, we have a hunch, right? That's why we do things. We have a hunch that this will be helpful on very many levels. So with the exploration, we kind of thought that just trying to make it more organized will actually help on these metrics as well. But yeah, that's I'm not sure whether it's just a side effect. It's is this thing that, okay, so I'm going to be brutally honest here. I always have troubles getting anything accepted to robotics conference if we don't show that we do better than some baseline, or we don't do proper experiments. So that's basically when we started making things a little bit more thorough in the way we analyze what we implemented, and we started focusing on the engineering side of the things a little bit more as well. And it makes perfect sense. It's just a little different mindset than in TCS community where as long as something is like a really pretty algorithm and it's very novel and original, it's very much appreciated. But now we have to make it work, and we have to make it work well. So that's what I think is that extra step that it took us a while to realize that this is what we need to be doing. And that's why I probably present it as like, this is a side effect, but of course we do it for a reason, and this is what we hope for. So yeah.
Yeah, no, but that's interesting, because this has to do with bridging these two communities that have similar but slightly different values in what they value. And so you kind of, to be a person at that intersection, you have to understand those things and understand what those reviewers are looking for. Yeah, that makes sense. So we've got two questions. So the first one is this: where do you see this intersection between fields in 5 years?
Yeah, that's really interesting. I really hope that it will get a little bit more momentum, that we will talk more and understand each other more, that TCS people will realize this is what robotics people appreciate, and robotics people will realize this is what can come out of TCS people, but we have to tell them what we actually need. So that's a very vague answer. I have no clue. I think that what will happen is that in TCS, what is being a lot appreciated is very general and universal solutions still, and broad analysis of things, and complexity and theoretical complexity and decidability and all these kind of things. So that's very nice. And then there is this robotics part that is very practical. So I think that if they start feeding into each other, maybe we will get like a little bit more tailored solutions from TCS. Things that are, not full LTL, but this fragment of LTL or this fragment of STL working super efficiently because there's this robotics problem that motivates us. And again, as everything in robotics, you cannot just design one tool for everything. You have to adjust and sort of make them fit one particular class of problems. And this is what I think will motivate TCS to narrow down the problems a little bit and fit it into robotics to help on particular solutions there. Yeah,
that makes sense, because if you're operating at a very high level of abstraction, how do you choose what you prefer? Well, if A is more general than B, then you prefer A. But once you actually got an actual domain in mind, now all of a sudden, yeah. So I see that. I think that's a tough question for sure. But that's I think a very good answer to that, a very concrete answer. So we have another question here, and it starts off by stirring up some controversy. So this is from Pierre, and he says, a few years ago, there was quite a controversial blog post about deep learning versus probabilistic graphical models versus logic that stated, and this is a quote, as of 2015, I pity the fool who prefers modus ponens over gradient descent. Now, this is the question. He says, since logic is much more than modus ponens, as of today, should we pity those who don't have formal methods in their toolboxes?
No, we should motivate them to include them. So definitely not. It's not a tool that fits every need. It's not a tool that I would use on every single robotics problem. It's a tool that makes sense in a particular situation. But, if you have learning, maybe you want some guarantees on top of that. So I wouldn't give up on formal methods as something that is, rigid. It's not. It's something that you should look for. What can this be good for in my particular settings? And if the answer is like pretty much nothing, then don't use it. That's fine. But I think that they have a lot to offer in terms of guarantees, and that's the complement to learning. That's what we should be using them for.
Yeah, so
not as a replacement, definitely not as a replacement, but as a complement that gives us a little bit better understanding or explanation. So in the talk, I deliberately did not use words like understanding or explanation or explainable. But if you think about it, that's one part of the things that we are trying to do with formal methods is adding some sort of understanding. And when we talk about things like trust, then formal methods is something that can increase the trust. We talk about something like legislation. Maybe formal methods is a way to get some stuff to answer like what sort of legislation and certification should autonomous systems have. Maybe that formal methods will be the answer, maybe.
Well, I really liked when you were talking about the constraint relaxation, you had this little, the smallest example that illustrates the point, which is that stay in the right lane, don't go through the construction zone. What do you want me to do? And so it seems to me like you're talking about legislation. It makes me think that so often there's so many rules that are like that if you were to try to formalize them.
Yeah.
And I know that I don't know, was it 30 years ago when they had sort of the Open Psych project and they were trying to collect formal descriptions of common sense knowledge. They discovered how hard that really is. And so even the process, even if it's not about the tool, just the process of trying to solidify it and boil it down kind of really brings these things to light, which I think is also very valuable. So one thing that you said, and you kind of touched on it now, but you said it in your talk that I thought was quite interesting, is you said, you know, here's a system and it's doing this, and then you said there are other parts that are built on top of. So there's a perception system, gesture recognition. These are some of the examples you gave in the beginning.
Yeah.
And you didn't leave it at that. You kind of came back to that at the end, and you said, oh, this is actually an area where we're going forward, where we're really beginning to think about that. And so I'm curious about that because you know, I have seen some papers where there's a place where the formal method technique is used just for the planning component. And, you know, I guess there's an idea that there's propositions and your sensor better just ground you to those propositions, and that's it. It doesn't say anything really about the sensor. But it sounds like you're thinking a lot more about that, or you have some thoughts. So could you share some of those ideas?
Absolutely. So it's not just me. I think it's the community, and there are a couple of people that do very interesting stuff that I don't do, but there is research on formal verification on neural networks, synthesis of neural networks used for formal synthesis and verification, and all these kind of branches. There's also, you know, work on if my perception system is this robust or this faulty, what guarantees can I give about the whole system? Can I kind of like compensate on it in the motion planning, in the planning phase, and so on? So that's where I think it's going. I think that we took the guarantees on the planning, but now we are trying to connect it a little bit to, for instance, perception by saying, what if I have this uncertainty in perception, or what if it's only this robust? Then I still want to have some guarantees. So you can take a look at it as that you will put the formal methods inside the perception, or you will put it in between the perception and the planning, or you will put it on planning and you will kind of like bloat it so that there is enough space to absorb all the uncertainty in the planning phase. So there are different approaches to that.
Oh, interesting. But yeah, so it sounds like sounds like an active area where people are thinking quite a lot about different
Definitely
ideas. Yeah. Interesting. So the other theme that really came out, maybe I should pause. We don't have another question, but those were great, those were great questions, excellent questions. I think better than any of the ones that I've asked. So I think we've got another one. Oh, this is a very nice question. Anonymous question, but the question is, what drew you to formal methods?
Come again?
The question is, what drew you to formal methods? What was it that about formal methods?
Okay.
Yeah. I like that question, because that's a little like when you interview an artist and you say, who are your inspirations? You know, and they say, oh, you know, yeah. So.
I think when I was a bachelor student at the Masaryk University, which is kind of like, there is no robotics program there whatsoever, but there's a very strong theoretical computer science program there. Someone showed me, like there was a selection of lab that we could get engaged with, and one lab presented this video of falling Ariane 5. And they said, this was a software bug in there, you know, and all of that could have been prevented if they did the formal verification. And I'm like, I could save lives. I could, you know, save rockets from falling. That's what I want to do. And that's where I started looking into formal methods, because there was this really pretty math in it, really, really pretty math. And on top of it, there was this like strong motivation. Of course, it was a little bit, you know, motivational example. It was still a little detached from reality what we were doing there, but still, that was it.
Oh, that's excellent. Yeah, no, I as an undergrad also saw the Ariane 5 disaster. Yeah, and had it beaten into us, and so yeah, that's a great That's an excellent question, and a really nice answer. One thing that I saw about your talk is that it has this. It talks. It starts by talking about what formal methods can give us. Guarantees and so on. And I also like that there was sort of a few places you really touched on the specification, the what versus the how, distinction between those two. But the thing that I kind of saw is across towards the end, there's this message that it's sort of, they're formal, but they're not rigid, right? And that these tools can be completely applicable in cases where there are interaction challenges. For example, in your interaction challenge where you've got you're thinking about formal methods for HRI, and I think that's very interesting that's the case. I guess I don't know how to turn this into a question, but you started to talk about, hinted to some of these things which arise, like there's a difference between provable and perception, perceived guarantees. Sure. Could you say a bit more about that? That's fascinating.
So it was. So that rigorous but not rigid, that's my take on the thing. I'm not sure how many formal methods people will agree with me, but that's the take that I have. But anywho, the provable safety versus perceived safety, that's something that we ran into when we started discussing trust and trustworthy autonomous systems. So with a couple other faculty and social roboticists that we have here, started talking about trustworthy autonomous systems. And for me, it meant like, okay, I'm going to have a proof behind it and I'm going to know what's going to happen and that's going to be provided by the proof. And they're like, no, that's not when people will trust them. People will trust them and they will perceive them as safe. So we started looking into a little bit into what's the difference between provable safety and perceived safety. And it's still very preliminary phase of this project, but it's a little bit part of that social acceptability, correct bike design and social acceptable planning project. But that's one thing that we think we need to address. Provable safety versus perceived safety, that's two different things.
Yeah, no, that's fascinating. I could say more. Maybe we will later on, or maybe we'll come back to that on the second session, because we've got a question here. We've only got 2 minutes, and it's actually got, I'm seeing 3 question marks here. So this may also be, maybe we touch on this and we can come back to it in a little bit. So the question is this. I'll just read all 3 of them. How good are we with formal methods in planning at the moment? Can we use it in many situations already? And what should young PhD students look into?
How good are we? Well,
yeah,
that's the first question. Well, I think we are pretty good. I don't really know how to quantify how good we are. I think that I mean, we can do temporal logics on top of sampling-based motion planning algorithms, and they do not perform much worse than without temporal logic goals. We have fairly scalable algorithms by now, so we can do a couple robots.
You kind of answered it in the beginning, right? You could write papers that show that these are competitive, right? Because roboticists care that it's competitive, and so they're competitive.
Yeah. So it really depends on the particular setting, I would say, but a couple of robots in like a decent environment depends on how complex is the. It depends on what are the assumptions, what we can rely on. So if I can rely on having a really good semantic map, or if I can rely on someone giving me partitioning, then it's like it's fairly applicable. But then if there are challenges like I cannot rely on this, or I have dynamic obstacles or people or something, then it's a little bit further. So I think that the applicability is like, as long as I have a single robot and everything is well modeled, then I'm good. If there are more robots, then there is a question mark how far I can go. If there are robots and people, then there are more question marks. So that's how I would say. What was the second question?
Well, so
or should we leave it?
Yeah, we're at the top of the hour. So the second question was this. I'll tell you the second question, but let's not answer it now. You can mull this over for the next 9 hours, and then you can come back with a good answer. Because it's a tricky one. The tricky one is, what should young roboticists, young PhD students look into?
Okay.
So that's not an easy question, but that may be one we can start the next Q&A with.
Sounds great.
Does that work out?
Sounds great.
Okay.
Thank you very much
for the questions, and thank you so much for the answers, and for making yourself available, and helping feel that this conference is not just a television channel. There's some actual interactions, some things that are actually going on, and you can talk to the experts in the field. So thank you, Jana, so much. And
thank you so much.
I'll see you much later. Bye.
Bye.